So we are going to look at the last method of solving today for far as solving quadratics. We talked about solving by factoring. We talked about solving by square roots, last week, and then here we'll talk about the quadratic formula. And if you kind of think about, what I've been talking to you guys about, this idea of like having a toolbox, and when you go to factor, there are all these different methods of factoring, and when one stops working, we pulled out a different tool and started using it, and then until it stopped working. So you kind of think about this in that same way that solving by factoring, was a good tool as long as it worked, but it only worked on certain types of problems, and then we were able to, oh, what if it looked like this? Then we could solve it by using these square roots, but again, that only works on certain types of problems, and so then bringing in this last kind of tool in our toolbox here with the quadratic formula. So you kind of think about the factoring as being like a screwdriver, and so if the problem looks like a certain way, then we can use our screwdriver to solve it. And then if the solve by square roots is like maybe a little hammer or something like that, so it's not a screw anymore, but it's a little nail that we need to pound in to get the problem done. Well, I'd call the quadratic formula kind of the sledgehammer. That if you want to take the sledgehammer and pound on a screw, you can still get it into the wall. You can take the sledgehammer and you can pound on the nail and still get it into the wall. It's just going to be a little bit messy. So this method will always work. Okay, it's just that it's kind of a messy method. And so if you can factor, you should probably factor. If you can use the square roots, you should probably do square roots. If you can't do either of those things, then we bring out this and say, well, here's what we should, here's how we get the answer for the ones that don't work this other way. So, I'm just kind of thinking about that. And I know I kind of talked about Friday. It's like, there will be problems that say solve by factoring, so we expect you to do it that way. And, solve by square roots, so we expect you to do it that way. Solve by the quadratic formula, so we expect you to do it that way. And there may very well be a problem that says just solve, and so then you get to pick the method. In that case, if you decide to use the quadratic formula, you will get the right answers. It's just you could have possibly done it a different way and done it faster with one of the other ones, in an easier way. So just something to think about. So the quadratic formula can only be used on equations that are in the form ax squared plus bx plus c does need to be equal to 0 in order for us to use the quadratic formula. There's a couple other kind of restrictions. Of course, a cannot be 0, because if a was 0, then there'd be 0x squared, and then it wouldn't be a quadratic. And then you're like, why are you trying to use a quadratic formula if it's not a quadratic? You silly goose. And then a and b and c need to be real numbers. We were just talking about imaginary numbers the other day. So, if you had an I in here, if it was, then you wouldn't be able to do this. So there are a couple restrictions, but so it must look like that, and a couple restrictions on like what A, B, and C can be, but real numbers, pretty broad category. So what is the quadratic formula? So it does solve for x. So it's x equals, and it's negative b plus or minus square root. So I'm just going to start my radical, but I'm not going to finish it. B squared minus 4ac. Now I'm going to finish my radical. All over, so make sure I have a nice long fraction bar here. 2a. So that is the quadratic formula. So make sure you get that written down correctly. So you can see it's kind of an intense formula, and you can actually also see part of something else we talked about. You might recognize this. Right? Negative b over 2a. There's something we spent quite a bit of time talking about. It's part of the quadratic formula. So we're going to use this to solve some equations. That's really all we're going to work on today, is just kind of using this tool to see how it works and how to kind of best implement it. I guess what I'll be focusing on you guys is trying to highlight some common mistakes that I see. Just kind of warning you guys about those things, and maybe trying to show you a smoother way to do this. Okay. Oh, Audrey, you showed up. Let's see. Okay, so the first thing we want when we go to use the quadratic formula is we want to make sure that it's equal to 0. Okay. So with a problem like this, we can move right beyond that. Okay. Second thing you might want to do, especially as you're starting off this, is go ahead and write down what A and B and C equal. Just as a, just like we did with AC method stuff, and eventually you don't need to do it anymore. But sometimes it's a good idea when you're starting something like this where it's so complex to do that. So of course A is 1, right? We have a 1 there. And our B value is -5, and our C value is -14. And the next thing we're going to do is just plug all those things into the formula and really just simplify it down. Okay. So because it already says x equals, right? We actually don't have to solve for x in that typical way, like where we had to do last time, like get x by itself. That's how we solve. X is already by itself. Our job is just to look at the formula and basically simplify all that math down until we get our answers. So it's just simplifying, not really solving per se. So what I like to do, I've probably mentioned this term before to you guys, is just basically set up my shells. Okay? So x equals, and then I'm going to go through and basically take all the letters out of the formula. But I'm going to leave all the other symbols there. So I have -b, but I'm just going to put negative, and then I'm going to leave a space for myself to plug stuff in. So negative something, plus or minus, square root, or radical sign, but I'm not going to close it yet. And then something squared minus, it's always a 4, -4 times something times something. And then I'm going to bring my radical over. And then I'm going to go and draw a big old fraction bar, make sure it's under everything. And then 2 times something on the bottom. Okay. So I just like to do that. Again, it just leaves me all the places to plug stuff in. And I can make sure that I have all like the standard parts there, right? Like, did I get my negative here, right? Do I have my plus minus? Do I have my square? Do I have a -4 here? Do I have 2? Like, that's the stuff that should always be there, okay? And then I can go back and focus on the stuff that's particular to this problem, which is my B's, my A's, and my C values, okay? So I call that like setting up my shells. That's just something I say. And so, the first thing that the quadratic formula wants from us is B, right? And you might notice that B shows up twice, okay? So grab my B value, it goes in here, and that goes in there. All right, and then it says -4a, right? So I need my A value, and I might notice that A shows up twice. Looking at these, right? And then I go, okay, my A value is 1, so I'll plug 1s into those spots. And then what we're missing, right? C, your C value here. -14. And I really would suggest you guys go back and double, triple check. Did you get the right numbers plugged in to the right spots? Okay? Because if you plug in B where you're supposed to plug in A, there's no way to get the right answer, right? If you plug in C where there's supposed to be a B, there's no way to get the right answer. So you can, mostly get everything else right. Like if you plug in one wrong number and then you do all the other math right, you'll still get the wrong answers, but at least I'll be able to tell that you did most everything right. Just had one little mistake at the beginning of the problem that messed you up. So it's not like the death of you. If it was just purely right or wrong, then obviously it would be wrong. But since we do ask you guys to show your work, we can see that you made just one little mistake. So just double, triple check make sure you plug the right things in. Okay? So the rest is all simplifying, and I want to kind of go through like what I would suggest would be the best kind of process in order to go do that, so you don't make a bunch of mistakes. Okay? Because there's a lot of arithmetic to do here, so just making some silly mistakes. So What I'd suggest you guys do first is to look at the stuff on the outside of the radical. So these two things, and just simplify those, because those should be really easy just to do in your head. Okay, so that equals, so of course negative negative 5, right? Well, it's so important that we have the negative on the outside and we bring in the right number. It's negative negative, so that's positive 5. And then my plus minus, and I'm going to start my radical, but I'm not going to do anything yet. And then of course on the bottom, 2 times 1 is just 2. Okay, so that's just going to sit there. Next place I would tell you to look at is the square. Okay? Can't tell you how many times I've seen people make stupid mistakes with that, something that's really so simple, negative 5 squared. Okay? And for whatever reason, people are typing this in their calculator. And there's a couple questions I have about that. One, why are you typing negative 5 squared in your calculator? You should know the answer to that. 2, when it tells you that it's negative 25, why are you accepting that as an answer? Okay. Why are you doing something that you should know in a calculator? And 2, why are you accepting the wrong answer from the calculator back? Okay? Because you typed it wrong, it's telling you the wrong thing. Why are you accepting that as an answer? Right? Anytime we square a number, what should we always get back? Anytime we square a number, what should we always get back? Take negative 5 times negative 5. What do we get back? Take 3 times 3. What do we get back? Negative 11 times negative 11. What do we get back? All right, into positive. That's a public chat idea there. Okay? Anytime you square a number, you always get a positive number back. There's no way it's negative. You're typing it in wrong, so your calculator is telling you the wrong thing. If you're, for some reason you need to, say you don't know what negative 13 squared is. Sure, that's more reasonable. Okay? But even then, why are you typing in the negatives? You should know that the answer is positive, right? You don't need the calculator to tell you. Maybe you don't know what 13 squared is. That's fine. Okay? I suggested that you do, but maybe you don't. Okay? You should know 5 squared. Okay? But even then, if you don't know what negative 13 squared is, then type in what 13 squared is, because that's the same thing. Or if you type it wrong, and it says, hey, I'm negative 169, you're like, oh, but squares are always positive. That's what I want to type in. I'm going to write down 169, not negative 169. Okay? So that you're thinking either about what I should be typing, or if I do type it wrong, what my answer actually is supposed to be. Okay? Do I actually need a calculator to tell me what negative 5 squared is? You shouldn't. Okay? And do I need a calculator to tell me what a negative squared is? You shouldn't. Okay? But I've seen many people make that mistake, or one of those mistakes. Of course, negative 5 squared is 25. And then I would go on to this part. Again, signs are such a huge issue. How many negatives are there? How many negatives are there? Garrett, how many negatives do you see there?
You say my.
I did say your name, Garrett.
In the square root, I believe there's 3.
No, in the green that I just highlighted.
Oh, in the green, there's only 2.
Okay, so what's that mean about our answer?
That's positive.
Positive. Okay. Okay. You need a calculator to tell you that? Shouldn't, right? So you look at that, and the first thing you guys should be addressing is what's the sign of what's here, right? So, there's a little bit of mental flexibility you guys need, right? This is a -4 sometimes, but now, at the moment, I'm thinking about it as a -4, okay? So because of what I'm doing here with multiplication, that needs to be a -4. So negative and negative gives me a positive. Then I worry about what the numbers are. I stop worrying about the signs. 4 times 1 times 14. Okay? Well, 4 times 10 is 40. 4 times 4 is 16. 40 plus 16 is 56. I get positive 56 there. Okay? So really pay attention to your signs. Okay? Silly mistakes like that. All right, so what's the next thing we should do to simplify this? All right, so now we're looking under the radical, still not done simplifying that. So 25 plus 56 is 81. So I get 5 plus or minus the square root of 81 over 2. Okay. So at this point, you should be looking at this and saying, can I reduce this? Can I simplify that? What's the method we use to reduce radicals? What do I call that? Cam, what's the method we use to reduce radicals? Samantha, what's the method we use to reduce radicals? Jake, what's the method we use to reduce radicals?
Sock method.
Yeah, sock method. Okay. So do we need to sock this out?
No,
Why not?
because it's a perfect square.
It is a perfect square, exactly. All right, so recognizing it for what it is, that sock method is not there to make you guys do something that you already know how to do differently. It's to help you with the things you don't know how to do. So if we said the square root of 80, then the sock is there for you. Okay? Square root of 81, though, you should know. Okay, 8, good lord. Okay, 9. All right. And so because this is what it is, right, that it's 5 plus 9, right, and it's 5 minus 9, because that's math we can do. It doesn't say like 5 plus the square root of 3 or 5 minus 2i, okay, so math that we can't do. Because this is math we can do, we are going to go ahead and do it. So at this point, we're going to take this problem, we're going to split it into 2 new problems. Okay, so I'm going to do 5 plus 9 divided by 2, which is 14 divided by 2, which is 7. Then do 5 minus 9 divided by 2, which is negative 4 divided by 2, which is negative 2. So there we got 2 nice answers. Okay. So that problem turned out all pretty. I got 2 nice answers. So remember what we're doing there. By solving a problem, we're also finding its x-intercepts, we're also finding its roots, we're also finding its zeros. So if we think about this problem in the way that we were given it, going back to the very first equation, the beginning of the equation, we saw that our y-intercept was down there at negative 14. And then we just saw that one of our x-intercepts was, about negative 2. The other x-intercept was over here at 7. Okay, which means that our graph, and it opens, up because the positive x squared there. So our graph would do something like that. Okay. So remember, your solutions are also your x-intercepts, are also your zeros. They're also called your roots. Okay. So we had a couple names for those, but in this case, we're mainly focusing on the fact that they're also called x-intercepts. Seeing that they give us those 2 points there. Okay. Because that problem gave us nice answers like that, it actually tells us that we could have factored it. We could have factored that faster. And then we solved it that way. So, factors A is 1, C is negative 14, so we could have found our factors of negative 14 that had to be negative 5. Those would have been negative 7 and positive 2. And as we get down here, we see that the answers are positive 7, negative 2. We do that final solving bit to, when the sign switches there at the end. So, okay, but there's our 2 answers. X equals 7 and negative 2. Okay. We're going to do another one together. So remember step 1, want it equal to 0. So this one's not set equal to 0, so we need to get it. And so in that way, you actually want to keep the x squared positive.
Can you go back?
Sure. So when you're doing that, keep the x squared positive. Right? So it may seem like less work to move the x squared over to the right, but you actually want to move everything else to the left. So that'll stay positive. It's much easier to solve things when the square term is positive. Okay, so we give me x squared minus 2x plus 5 equals 0. You good, Audrey?
I'm good.
Again, at the beginning, you may want to write down, what A, B, and C are. Okay. So our A value is 1 again, our B value is -2, and our C value is 5. Then we're just going to plug it all into the quadratic formula again. I'm going to set up my shells. So negative b plus or minus square root something squared minus 4 times something times something. You guys should be looking back at your quadratic formula you wrote down earlier, following along with that. Okay. But what I'm going to be doing is checking to make sure I got my negative. Did I get my plus minus? Did I get my square? Did I get my -4? Right? Did I get my 2? Right? All those little things that are always there. And then I can go back and fill in the things for this problem. Okay. Yeah, that's something I like to do. It's not necessarily as far as that part like that you guys really need to do for yourself. But again, I think about my first spot, right? That first spot's supposed to be B. So going back and looking at the formula, right? First spot's supposed to be B, and then I have another B over here. So I'm just going to make sure I put the the B value in there twice. So my B value is -2. So -2, -2. Next one, so -4 times A. So my A value being 1, and then we have another place where A goes, right? There's 2 places for A. So 1 and a 1, and then the last one is C. My C value is 5. Get my 5 in there. Again, at that point, you really should double, triple check, right? Did all the numbers get into the right spots? Did all the signs carry over like they were supposed to, right? And make sure those are both -2s and stuff like that. Okay. Again, just the method I would take in simplifying this, just to help you guys be more successful at it, right? Avoid the mistakes that I've seen over and over and over and over again. So just deal with those things that are on the outside of the radical first, right? I got a double negative there. Let's make sure we deal with that. I got 2 times the 1 on the bottom. Let's make sure I deal with that. Okay, the easy stuff. So I got a double negative, so that's a +2. Got my big old fraction bar, got my plus minus, and then I've got a +2 on the bottom as well. Okay. And again, I like to start my radical. I don't finish it until I know how much room I need. And then I look at that square. I go, right? Square's always positive. Square's always positive. 2 squared. I know what 2 squared is. I don't need a calculator to tell me what 2 squared is. 4. Okay. And then look at the next part. I look at the whole thing first. I don't look at the numbers. I'm looking at the signs. So what I notice there is there's 1 negative there. So that immediately says, okay, I got a negative, right? I then look at the numbers. Don't care what the number is. I know it's a minus, whatever it is. Now that I know that, now I'm going to go back and look at the numbers and say, ignore all the signs. Say 4 times 1 is 4, times 5 is 20. Then I write a 20 there. Okay? By separating the signs away from the numbers, it helps me make sure that I don't make a mistake. Okay? So that's why I do that. Then I close that off so I know what my math needs, how big my math is now. And then I still need to work under this. I'm not done with this underneath radical. So 2 plus or minus over 2 square root. So 4 minus 20 is negative 16. What does this mean about our answer? What is that telling us about our answer?
It's going to have the imaginary I.
Good job, Jared. Imaginary. Okay, so we're gonna have an I, and that means our answers are imaginary. Okay, and so we talked about how to deal with that. Right, take that square root of 16, negative 16, and you break it apart into a square root of 16. You break it apart into a negative 1, square root of negative 1. And how we square root negative 1 is with our I, right? That's equal to I. Right? And then, do we need the sock method here? Yeah, right. We should know that, right? Square root of 16 is 4. So why would we waste our time doing the sock method? We know it already, right? So we have 4 times I. So we just did that. So x equals, so we have our 2, our plus minus, our 4i that we just found, and our 2. So notice how I didn't try to divide here, right? Like, oh, they all have 2's in them. I'm going to take a 2 out of everything. Can't do that right there, okay? Because this is not a negative 16. It's the square root of negative 16, which is not equal to negative 16. I can't divide it by 2 in a way that we think we could. Okay? Normal numbers can't interact with numbers that are underneath radicals. Okay? They can't. So there's no way for me to divide right now. Now that I have no more radicals, now I can start saying, hey, can I reduce this? So this is when the division gets to happen. This is when the reducing of the fraction gets to happen. When everything else has been reduced, then we divide. Right? Just go back to the last problem. Right? When did that 2 finally get to do its job? Right? That 2 is hanging out until the very last step. That's when the division gets to happen. It couldn't do it any other time. Okay? So the division is the very last thing we get to do here. And in order for us to reduce this, right? So this is really the question that you should be asking is, can we reduce this? Okay? Where we need to look in order to reduce is at every piece of this and say, can they all be divided by something? It's kind of like when we were doing GCF, a while ago. Like I was looking at all the terms and can I take something out of all of them? And if they didn't all share something, then we couldn't, right? So it's the same way here. This 2 is trying to divide both of these things. And if they're not both divisible by 2, then I can't do the division. Well, but all of these are divisible by 2, right? So in this problem, it does reduce. So when you have 1 divided by 2 is 1, and 4i divided by 2 is just 2i. And then the 2 on the bottom, 2 divided by 2 is 1, right? But the simplest way to write that, I don't need that 1 on the bottom. So the simplest way to write that would be 1 plus 2i. Or sorry, 1 plus or minus 2i. So there's our 2 answers, right? And we can't take 1 and actually add it to 2i. They're not. It's kind of like terms. I can't add a 1 to 2 imaginary things. Okay, and so we can't actually do that math. We can say we want to do it, but we don't get like 3i or anything like that. It doesn't work. If I had 1i plus 2 i's, then I'd have 3 i's or 4, depending on how you count. Right? But since they're different types of numbers, we can't actually add them or subtract them. So how does that fit with the graph, right? We found the x-intercepts last time. We had 7 and negative 2. Those are x-intercepts. Here we have 1 plus 2i and 1 minus 2i. Remember what that means. Like Jarrett said, these are imaginary numbers here. We know our our y-intercept is 5. And that this graph opens up. And it turns out that when we try to draw it, it would look like this. Right? It would never hit the x-axis, right? That's why they're imaginary, because they don't actually exist. So no x-intercepts on this problem. We can solve it, but we get imaginary or complex answers, not real answers, and no real x-intercepts. we see one nice problem. We see one problem where they give us imaginary solutions. Anything feeling weird right now? I'm gonna start asking you guys questions on how to get through the next one. Then I'll have you guys do the next one all on your own. Anything so far feeling weird? Audrey, we okay to move on?
I'm good.
Okay. All right. I'm going to pull this one to a different page. Just run out of space here. All right. So what's our first step? Cam, what's our first step? Mason, here, what's our first step? June, what's our first step? Zoe, what's our first step? Tion, what's our first step? Mr. Upton, what's our first step? Jake, what's our first step? Brian, what's our first step?
Equal to 0.
What's that?
I'm already halfway done with the problem, but it's equal to 0.
Get it equal to 0? Okay.
Yeah, you have to plus the 6 to the other side.
Okay. So add 6 to their side. All right, Jake. Okay. Again, step 2, you feel that out for yourself. If you think you need to do that, if you need to write down what A is, you need to write down what B is, you need to write down C what is. Again, it's a good kind of starter. We got 1, 6, and 6. Okay. And then we should write y equals here, right? Because that's y that we're solving for, not x. Then you need to have a negative something, plus or minus something, square root, something squared, minus 4 times something, all over 2 times something. There's a song out there somewhere. I am not a singer. It's not my thing, so I know some of the other teachers sing at their students. It's just some pop, normal, like, it's not happy birthday, but it's something like that where you just sing the letters. It's nothing to the beat of the song, but again, I'm not a singer. I don't do that stuff. So looking back at the formula or whatever, right? Camilla, what should go here? Camilla, what should go here? June, what should go here? Kenzie, what should go here?
Is it 6?
6. Who was that?
3.
Audrey? Why is it 6, Audrey?
I kind of just looked at the other problem and saw you put the B right there.
Okay, because the B 6, you gotta be careful, right? Because we got a couple different 6s, so B is there. Okay. June, Camilla, Tion, Zoe, what's in our next spot?
Six.
June, okay. Which 6, June?
The first one.
The first one, B, yep. So we're using B again, right? So, oops. B shows up twice there. Okay, thanks, June. Kamala, Zoe, Tion, what's our next one?
1.
1. Who's that?
It's Tian.
Tion. All right, Tion. 1. All right, A value. Does the 1 go anywhere else, Tion? Does A go anywhere else?
It goes by the 2.
Goes by the 2. Okay. All right. Mr. Upton, Brian, what goes in our last spot? Oops.
Would it be 6?
Yeah. Zoe, 6?
Yeah.
Which 6?
In the last spot?
Okay. The C? Is that what you're trying to say? Yeah, so it's a little weird, right? Because we have a couple different 6s here, so it's just watching out for that. We don't get the 6s mixed up. You know, it seemed like it might not make a difference, but if you're trying to learn a pattern, then it would be a problem. Again, I would just kind of start on those outside, simplifying, right? So we're dealing with those two things there. So there we just have -6, plus or minus, start my radical, and then 2 times 1 again on the bottom. Then the 6 squared, right? You don't need a calculator to tell you what 6 squared is, 36. And then the multiplication here, right? So just, again, always the sign, watch your signs, watch your signs, watch your signs. There's 1 negative there. So minus, and then 4 times 1 times 6 is 24. So minus 24 there. Then I'm ready to close my radical. And I head back under the radical and look at that. And again, I'm not trying to divide right now, like, oh, look at all those are divisible by 2. I'm going to take a 2 out of everything. Bad idea. Okay, so instead what we're doing is still simplifying that numerator. So y equals -6 plus or minus the square root 36 minus 24 is 12 and then over 2. So then I should divide everything by 2 and get -6 plus or minus the square root of 6. Oops, I didn't take that 2 out, did I? -3 plus or minus the square root of... That's odd. Sorry about that. Is that the appropriate thing to do there?
No.
No, not, not okay to do that. Right, we don't do the division there. Right, division is the very last thing we do. What should we be looking at? Right. Should be looking at this and saying, can we reduce that? Can we reduce the radical? Okay. Again, it's a question. Can you do that? You should be looking to see if you can. Okay. Why is it doing this to me? All right. So we take that 12, right? And so we look at the 12. Sock that out to 6, 2, and 3. So I've got it all socked out. What do I do now that it's all socked out?
You group them.
Group them. As Audrey likes to say, look for buddies. So we got a buddy, pair of buddies of 2s, and we got a lonely 3. What happens if you're a buddy?
You go outside the radical.
Outside the radical. So we got 1 group of 2s means we get 1 2 out. Right? That's a 4 that turns into a 2 as we square root it. And if you're lonely, what happens?
Inside.
Inside.
Yeah, stay inside. All right. All right. And then we can look, right? Can we do anything else on the top, right? Can we actually do that math? Can we take 6 and add 2 square roots of 3 to it, right? They're different types of numbers, so we can't do that. We got a calculator, we could get a decimal approximation of it, but we can't actually do the math. Okay? So at that point, we're done with any arithmetic that we can do on the top. And so now we can say we can reduce the fraction, right? And so again, with that reduction, where do we have to look, to see, do all 3 of those things have something in common? So notice how I didn't highlight this, right? I don't care about that. It's the normal numbers I need to look at. Can I do this? Okay, and so all of those are divisible by 2. Okay, it's the same thing like if I said what's negative 6 plus 2x divided by 2. Like I can do that because they all have a 2 in them. I don't need to worry about the x. I'm just trying to take a 2 out of everything. So it's the same way I don't have to worry about the radical 3. I just know that I have 2 of them. I can divide 2 things, whatever they are, into by 2. So, okay. So since those are all divisible by 2, so that'd give me negative 3 plus or minus 1 radical 3 over 3. That's a really complicated way of saying that, which more simple would be negative 3 plus or minus radical 3. I don't know why I put a 3 down there, sorry. Should be a 1. Right, so I don't need these 1s here. Okay, so that's the simplest way to write that. So there are 2 answers, right? So what that stands for is negative 3 plus the square root of 3 and negative 3 minus the square root of 3. So how to read that is like a value later. Negative 3 plus radical 3, negative 3 minus radical 3. Just kind of like an if here for you if you want to see that. If y equaled negative 6 plus or minus 5 radical 3 over 2. That would not be reducible. Okay, so there's nothing to reduce there because they don't all share something. So that would mean that you're done. Okay, there's nothing else you can do with that, so you're done. Okay, it is not okay to look at those and say, oh, I'm going to divide those by, and then leave the 5. Okay, it's not okay to just divide part of the problem because this says 2 is dividing everything. I can't just divide this and say I'm good. Right? It has to be able to divide both. So it's not okay just to do part like I did here. Right? So it's not okay. So just again, a common mistake I've seen happen a lot. They all 3 have to share something in order to reduce out. Okay. Again, the kind of last thing I want to talk to you about on this is the graphing side of things. If I go back to look at this problem here, and I'm just going to think about it as x's instead of y's, so x squared plus 6x plus 6, what this would look like. So we know from the problem that our y-intercept is 6. So these are kind of hard to understand, right? Negative 3 plus the square root of 3. So you can always type that into a calculator, negative 3 plus the square root of 3. The square root of 3 is about 1.7. So negative 3 plus 1.7 would be about negative 1.3. So I would have an x-intercept about here, negative 1.3. And then I'd have negative 3 minus 1.7, so it'd be negative 4.7. So somewhere over here closer to negative 5, there'd be another x-intercept. And our graph would do something like this. Something like that. So again, these are real numbers. They're just messy numbers. They're just messy decimals. Okay, but they are real, so they do actually hit the x-axis. Versus the imaginary ones, right? So we wouldn't hit the x-axis because those are imaginary numbers. No touching the x-axis versus here, just touching at messy decimals. You guys ready to try one on your own?
Can you hold on this one really quick?
Sure.
A little confused how it's in the negative part of the court, like.
We'll have to do it over here.
Yeah.
So I have negative 3 plus, and then the square root of 3 is about 1.7. Okay. So negative 3 plus 1.7 is negative 1.3. So that's why I put there.
All right.
And
how'd you get the blue one?
Negative 3 minus 1.7 would be negative 4.7. So negative 3 minus 1.7 would be negative 4.7. So that's where I got that one.
Okay.
Okay. I knew that my vertex had to be somewhere there between them, right? And then
Yeah.
So.
All right.
No worries. Any other questions on this one? So you guys have seen all the different kind of iterations here. Like, you saw one with nice, pretty numbers. You saw one with imaginary answers. You saw one with a radical in it still. Okay? I mean, that's about all that can happen as far as the way these end up looking. And it's kind of like what we saw on Friday with the square root stuff. The way, some can be really pretty and some can be kind of gross like this. All right, well, you guys try this one up here at the top, and then we'll be done. What you should have gotten 3 when you're done. Just plain old 3. Interesting that we only have one answer. Technically, we have 2 answers. It's just the same answer twice. And so this is something I mentioned a while ago. It's called a double root. It's something we'll talk about next semester. But when it comes down and just hits that x-axis once and then bounces like that, so that what that tells us is that that answer is actually a double root. It's the only answer to that problem, even though it should have 2. It's only a unique answer. And I was showing you guys up here how we could have actually factored that to solve it and would have solved faster, most likely, if you just factored instead. So again, quadratic formula is a great tool, but it's a heavy tool. So if you can use other things, I would suggest that you do. If there's only one x squared in there and no x's, then I would use square rooting. It's a lot easier. Just the way those two canceled each other, right? Square root of 0 is 0. So 12 plus 0 is 12. 12 minus 0 is 12. So tomorrow we'll just kind of start reviewing, factoring, solving square root, working with the radical stuff. So and again, any of you guys that are at all right, so one side's already equal to 0, so don't need to worry about that part of the step. Let's see. So my A value is 6, my B value is 4, and my C value is 11. So x equals negative something plus or minus square root something squared minus 4 times something all over 2 times something. First bubble is always my B value, and then second bubble is always my B value. So 4 and 4. Next bubble is always my A, and then the bottom bubble is always my A. So then I get a 6 and a 6, and then the last bubble is always my C. So I get my 11 there. And then I start simplifying. So x equals that first, right? So just doing those outsides. Looking here. So I get negative 4, and my plus minus my radical all over 2 times 6, which is 12. Then I go inside and look at my square. Of course, 4 squared is 16. Then I go look at the multiplication. So I see 1 minus sign there, or minus. 4 times 6 times 11. Well, 6 times 11 is 66. 4 times 60 is 240. 4 times 6 is 24. 240 is 24. It'd be 264. So 264 there. And I'll look under my radical. So equals negative 4 plus or minus over 12 square root. So 264 minus 16 would be 48. So 248. So definitely have something I need to reduce with the sock. And I also know I don't have an I with it. So I'm going to be looking at my radical here and seeing how I can reduce that. I'm going to break it apart first. 248 times negative 1. It's 2 times 124, which is 2 times 62, which is 2 times 31, and 31 is prime. So I got a pair of 2's, one only 2 and low only 31. And then I got my I. So I get x equals -4 plus or minus all over 12. So that pair of 2's gets to come out. My I gets to come out. The 2 and the 31 both stay under and multiply back together, so that gives me 62. A pretty crazy answer here. So -4 plus or minus 2i radical 62, all divided by 12. At this point, I should be looking here if I can divide. Not here, here. So can I reduce all of these by something? So again, I didn't even highlight the I. I'm just looking at the real numbers here. Well, those all are divisible by 2. So I'm going to take a 2 out of every one of those. So -4 divided by 2 is -2. 2i divided by 2 would just be 1i, so just an I. Square root of 62 didn't change. And then 12 divided by 2 is 6. So there would be my 2 answers here. 2 plus I radical 62, and then 2 minus I radical 62, and all that divided by 6. So again, not really anything we have a concept of what that would look like. Again, the idea here that the the intercept here would have been at -11. There you have a very steep, very narrow, skinny parabola because it's stretching by a factor of 6. So graph would end up hitting that graph at 11, hitting the coordinate plane at 11. It would do something like this. So it would never even touch the x-axis. So that's why for those imaginary x-intercepts come into play, it would do something like that. So, alrighty, hope you guys do well with that. Just take your time, go slow, moving through the steps. You don't rush and make silly mistakes with your signs and things like that. Have a good day.